Good evening, everyone. This is Melissa Raspberry from the American Institutes for Research. We have the honor and privilege of serving as the organizers and managers of the CS for All Teachers community. And we're super excited tonight to have this wonderful panel of guests that are with us. You have these lovely folks at the top of your screen. I feel like we're on a version of, I was about to say Family Feud, but that's not it. The Partridge Family, that's what I was trying to say. We're glad to have you here tonight, and I know that it's a particularly busy time of year as you start to close out the school year, but I was really excited when Ashley started talking about this topic and really wanted to take some time to reflect on the year and just kind of think about those things that went well, what didn't go well, because oftentimes, you know, as you go to close out and go into the summertime, some of those things kind of slip away. So this would be a great time to kind of think about, collect some ideas, so then after you give yourself a little bit of break to rejuvenate, you can get right back started into that, into the summer as you plan ahead for the 2018-2019 school year. It's crazy to me. I don't know how we're already at June, but we're glad to have you here tonight. We have a small but mighty group that's joining, so we hope that those of you that are here listening and participating will be actively involved. We do ask that you get connected either through your microphone or your telephone, and that option should have been given to you at the beginning, but I'll also put it in the chat window once I'm finished about how you get connected to audio, because there will be a participatory time in the conversation where we'll ask for your questions, and we want to hear them physically. You can always use the chat window, but orally is also helpful, and we really want to have a kind of engaging conversation here. We are recording this tonight for those who couldn't be here, and we'll share that recording link on the CS for All Teachers website. But the only other thing I would just ask that you do is that while folks are presenting, if you all would just please mute yourself. I'm going to do the same. At the top of your toolbar, up at the very, very top, there should be a dark gray black bar, and there should be a microphone or a phone icon with a little drop-down arrow beside it, and if you click on that drop-down, it should allow you to mute. If you're connected by a telephone, you can also, like a cell phone, you can also mute there, and that will work. But it just cuts down on the background noise and makes things a little bit easier. But when the time comes, we want you to unmute yourself and to chime in with your questions. So without further ado, I'm going to turn things over to Ashley, and she'll get things started from here.
Hello, I'm Ashley Waring. And I've got some really excellent people, some CS minds in the elementary realm here with me tonight, and I'm really excited to hear everything they have to share and take some notes myself. So, but like I said, I'm Ashley Waring. I'm just going to kind of tell you what my position is and where I am, and then share some like random bit of information that maybe people don't know about me, and I'm going to get my panelists to do the same so we don't have to go through a whole bio or anything. But I'm Ashley Waring. I'm the STEAM teacher at Rocky Ridge in Hoover, and I'm like an undercover doomsday prepper. So like I like to like, you know, hoard water and things like that, like a crazy person. Anyway, April?
Hi, my name is April Chamberlain. I am currently the technology coordinator for Trustful City Schools. This is my 22nd year in education, and so I come from the classroom all the way up to teaching 990 kids every week in a computer lab to the district integration specialist, and now where I am, where I get to work with both sides. So interesting unknown fact about me is I have my rescue scuba diver's license.
Oops, sorry, it wasn't coming off mute. I'm Michael Stone. I'm the Director of Innovative Learning for the Public Education Foundation in Chattanooga. Prior to this role, I had the opportunity to serve as an Albert Einstein Fellow under Dr. Jan Cuny at the National Science Foundation, and before that had been teaching computer science and digital fabrication in Southeast Tennessee. Oh, and random thing, I'm an ambidextrous typer. I can type with both hands.
Oh, nice. All right, Jeff?
Let's see. Can you all hear me now?
Yeah. Yeah.
Hi, so I'm Jeff Gray. I'm a professor at University of Alabama in the computer science department. I've been working with K-12 outreach since 2003 through summer camps and robotics contests, and we started with the Google CS4HS grant that led into an NSF project that helped to train the first 50 teachers in Alabama in CS principles, and we had some online MOOCs for that as well. I also am a College Board APSI instructor for CS principles, as well as the Codeorg CSF K5 facilitator. I was one of the original 50, I think, that they started back in 2013. And I'm co-chairing our governor's Computer Science Advisory Council, and worked with some of the folks from all of K-12. So it's great to have such a kind of wide range of educational colleagues. My strange fact, I guess, I have 4 kids. That's not really strange, but so like Michael, I used to live in Nashville, and if anyone is out there in a second grade teacher, the thing I always introduce myself, Brad Paisley, the country music star, was my second grade teacher, and Brad and I moved to Nashville same time in '93, so kind of interesting country music stories to talk about.
Interesting. All right, Angela? I think you're muted. Hey, Angela, I think you're muted. We can't hear you. You're still muted.
In Shelby County Schools
Oh,
in Alabama. Can y'all hear me okay?
Yeah.
I knew it was going to do that to me. I'm at home, clearly. My 6-year-old is not. But I'm in my 24th year of education, and I spent over 16 years teaching secondary. I have developed a new love and appreciation, though, for those elementary teachers who handle our little ones every day, and I work in a district of 30 schools, so I see all realms and levels of education. But my love for technology started back in 2000 when I got to go to my first NEC conference, which is now ISPA, and really it's just developed and exploded over the last few years, and my passion right now is STEM learning and helping our teachers to include STEM activities and hands-on learning and more of that educational design process in their classrooms, because I think that's going to be a very important skill for our students to learn as they move forward. And I think elementary is the best place to start.
And what's your interesting fact about you?
Oh, well, I am a lefty, but I play all sports right-handed, and my son is full-on lefty. He does nothing right-handed or even right-footed. He even kicks a soccer ball with the left foot. So.
Oh, that's great. All right, so we're going to go ahead and move into our first question. Get through this bio. So the way the questions are geared is kind of, Vinny says that he's right-handed and left-footed. So our first question is kind of geared toward the K-1 realm, and we're going to talk about like what resources or lessons were your favorite this school year and why. And it doesn't just have to be this school year. You could talk about a couple of years ago if you want to. But I thought I would share something that I did with I call them my little ones because I see K through 5 in my building. But we did just a simple if-then Unplugged game. That was one of my favorite things that we did because by the end of it, we ended up doing an entire workout because of the stipulations that they put in each conditional. So it was like we had a deck of cards, and we would talk about the characteristics of the cards, and there's red and black, there's space cards and number cards. So I'd say, okay, so if I pull a red card, then what's our action going to be? And we ended up doing like 20 jumping jacks, do 10 sit-ups, and by the end of it, they just started changing it to like, we'll just stand up or sit down, because they started to figure out that we're going to have to keep doing this over and over. It's going to keep repeating itself. But that was really engaging, and like they talk about it still, and they refer to that lesson when we're talking about other things. So that's just one of my favorites, and it was really fun to do with them. So one of mine. Angela, did you have a resource or lesson for this one?
Yes, I actually got to go into a kindergarten classroom in one of our elementary schools back in March, and we did, elementary classrooms are really
set up for center type learning or rotation, so that fit just perfectly with what we did. And some of the students, while they were working on the Code.org and Hour of Code website, I took a small group of them and we rotated through the whole class to do dash and dot out in the hallway, because some of these things you just need a little more space than is in the classroom. So one of my tips I always tell teachers is, make sure you've got the space to do a coding or robotics activity if you're going to check out our robots that we have. And so one of the things I did not foresee is make sure you're clear about not dropping the robots, because 5- and 6-year-olds are not real careful with them. But I'll tell you, one of the most valuable things I learned is the vocabulary is very important with that age, because I use terms and I could tell by the looks on their faces they had no idea what I was talking about. So one of their favorite words, and even when I go back and see some of those students, they remember that I taught them about what it means to sync or to pair a device with a tablet. And I just think that's really neat. Some of the students in the class were ESL learners. Some of them were special needs students. So we had a whole variety of students, and I'm telling you, the engagement level was incredible. I was really impressed with how well they were engaged. But I also learned that sitting for too long doesn't work. You have to kind of get them up. And so we actually made the maze for dash out of the kids, their feet. So we lined up and we made little places, and then the one driving them tried to go through legs and around feet and all of that. So it was really fun. That was probably the highlight of my year, was working.
Yeah. And that could also, like, if you're thinking about dash and dot and trying to apply that to another context area, you're also teaching them, like, directions. Like, you could also apply the, like a compass rose, or you could just talk about, front, back, left, right. Because my kindergartners, if you were still learning left and right all the time, and I still have to go in. But, yeah, that's just an idea to interlace that, I guess.
One of the other things that we've tried to incorporate, especially for the younger ones, is the reading part, pairing books or having them read stories ahead of the coding lesson, because then they have something to kind of some background knowledge, especially for those ESL learners. They really could not figure out what I was doing there with these little robots. And so some stories to either follow up with or to do pre the coding lesson would have been great.
Great. Does anybody else
we haven't used? Yeah. So I haven't used this one, but we found it when we're doing some research. I also am the librarian coordinator. So when working with them, it was just a natural way to say, how can we work together? And so they were looking and found all sorts of just coding examples that they could do with books that their kindergarten and first grade teachers are already doing, like The Very Hungry Caterpillar. And so they just made a grid and had different parts and pieces of the story. And so as they read, they were like, how can the caterpillar make it to the leaf? And so it showed them, you got to go right. And so it's just a nice unplugged. And plus, when we're sharing with our teachers how to bring coding into the classroom, that's not so foreign, because they're already like, oh, I've got that book in my library, or I've got that one. And a lot of times we think when they see it in one, they go, I could do it with this book or with this book. And so it just kind of really expands. So I'm really excited to share that lesson with some of our younger ones, and have our librarians also lead the charge with computer science standards.
Yeah, that's awesome, really integrating computer science there.
So I worked with a number of elementary teachers, and we had a couple of kindergarten and first grade teachers. We bought a few of the Bebot hives, and what we'd loan out technology for teachers to use in their classrooms. And what we knew they could get out of it, Bebots have been used for a couple of years now to teach sort of sequential programming, sequential logic, right? Some thought about algorithm design at an entry level where you don't have a literacy barrier, right? What we love about them is there's just symbols of arrows, right? You don't have to be able to read to use them. But what we discovered, we had a teacher that started doing, she was launching her literacy units using Bebots, which was really fascinating. In particular, in first grade when she was talking about transition words. We had done a training for the teachers, and in the training we talked about sequencing and different coding aspects, and it was really fascinating because when we were talking about sequencing, we were referencing sequencing from a computer science standpoint as a CS vocab word. But when she heard sequencing, the teachers heard sequencing, they all went, yeah, like they were thinking about it from a literacy perspective strictly, and it turns out that the confluence is strong, right? There's an obvious synergy there. So it became an easy access point for those teachers because they felt like they already had expertise. So we had students that were doing, like, they would have to stand behind one of the activities that was really interesting. They got some cardboard boxes, and they were in pairs, and one kid would stand behind the cardboard box and was the programmer, and the other one was standing elsewhere and would tell the kid what to do, right? Like, they could see like what the challenge was. So they had to give commands, and they were being forced to use, or sort of being coerced into using transition words effectively in this authentic context as they shared with another student how to code their robot. We saw a lot of progress with that. And the other resource we really like is not nearly as expensive because it's free, was the CodeSpark Academy with the FOOs. Love that for kindergarten, first grade, second grade. Again, sort of pre-literacy coding platform, tablet-based, and they're still working on their web platform to come out of beta, but doing amazing work with that. I actually haven't looked in the last month, so I'm not sure if the web one is out of beta yet or not. But we really like it because it's a nice blend of sort of a gamified, puzzle-based introduction to coding, but then also sort of a Scratch-esque, open-ended side-scroller gaming platform where, you know, kindergarten, first, second grade kids can start creating their own games that feel authentic, right? They feel like apps they've played on their devices.
Yeah, that's a great stepping stone for what they do, what we want them to do in third, fourth, and fifth.
Right.
All right.
Oh,
all right, so
and the FOOs just added variables.
What did you say? I'm sorry.
Sorry, the FOOs just added variables, which is wonderful.
Yeah. Yeah. That's great. All right, so let's go ahead and scoot over to question 2, which is still talking about kindergarten, first grade, but really thinking about like the skills that we're trying to get them to master before they move on to second and third in computer science. One thing that I tried to work on a lot with the kindergarten, first graders this year was in like problem-solving situations, which obviously problem-solving is something that you want them to continuously improve on, but communicating with each other was a big thing, which, I mean, a lot of people, I guess, don't really think about that with computer science, but it really is a huge thing because that's how you end up solving problems, is that you communicate with other people to get their perspective or get their ideas to solve those problems. So we really worked on communication skills, and especially communication skills pertaining to like projects and problem solving, whether it was computer science or not. Let's see. Anybody else?
Can y'all hear me? Oh.
Yeah.
I was going to say collaboration is a big one too, just waiting, taking turns, being patient with the robots, especially if they're going to be connecting to them, that there's just wait time involved, and younger students just can be very impatient. They haven't, you know, they even could get angry with the device if it takes too long. And then on coding sites, just that perseverance, that willingness to work through. Of course, that probably applies to every age, but to not just give up and think they failed, they messed up, and, oh, this site isn't for me.
I think from a...
Go ahead, Michael.
I was just going to add, in terms of skills that I think we're hoping to get embedded or could start embedding K1, I think you could start introducing event-driven programming, right? When I do this, that happens. And I do think conditionals are certainly something that you can start to introduce. It feels very much like a rules and routine in their classroom, right? If it's lunchtime, we should line up. I mean, those kinds of things are transferable. And they have authentic context to attach those skills to cognitively. So I think they're prepared, and it opens the door for embedding those skills in a less tangible modality in upper grades in elementary school.
I also see like students doing the, I can't remember what everybody calls it, but the typing like this, pecking, I guess. So even something as basic as that, I know that our kindergarten and first grade already start working on that when they can. So, and that just seems like such a basic thing, but it's going to help them so much more in the years to come. So, no pecking. All right, so if nobody else wants to jump in, I'm going to go ahead and scoot us to question 3. So this is similar to our kindergarten first grade discussion, but more second and third grade, and what kind of resources or lessons were your favorite working with that age group, and why?
I'll jump in.
Go for it.
So sort of on the paid front, again, sort of with Angela on the robotics piece, I think robotics offer an interesting entry point for elementary students because it can feel like a toy that turns into work, and the transition is oftentimes seamless. There's a cost barrier sometimes involved, but we really liked for this age group the Fyro robot from Robotics EDU. It is made to integrate, I don't know if they publish this publicly, but it integrates perfectly with Lego pieces. And you can make all of these, like the chassis essentially is pre-made, and that's what the base of the robot is. But you can program it over Bluetooth with a drag and drop platform that's proprietary to them, but it's really similar to a lot of the drag and drop languages out there. But it also has the ability to be programmed with, it has a barcode reader. And so it comes with probably 150 cards. They look like playing cards that are directional cards, conditional cards, different, basically every different command you would want in the drag and drop language. They are tangible physical cards, so you can swipe the cards like a credit card, and as you swipe them, it's storing them in sequence, and you can use that to program it as well. So it's an interesting sort of hybrid of drag and drop programming that only moves the digital artifact and combining that with a physical medium. And then we've been using this free one. I'll put the barcode reading robot is the one, let's see, I think I've got a link for that. I'll drop it in here. Yeah, Fyro. So then the Google Drive link I just put in the chat as well is something that we've been seeing with this age group for debugging. It's a simple little unplugged activity. We call it Mr. Stick. It's just moving the stick band around. He's got a path he's supposed to do. And the commands, he has to follow the commands, but the commands don't match the path intentionally. And so the kids have to debug that path, but we do it as a relay race. And so the kids line up and do it in teams against each other, and they only get to fix one error at a time. And so it progresses from a known, like, small quantity of errors to a larger quantity of errors to an unknown amount of errors, where the instructions just say there's an error, or there are errors, and you have to find where they are. So it's an interesting opportunity to give kids sort of a gamified way to mess with debugging in a maybe a less threatening way.
Yeah, there are a lot of board games now that are coming out. You can even buy them at Target. I posted one link into the audience chat, and I think those start around 8 years old or so. So this may be the grade level where some of those board games can even be useful to teach logic and coding in that kind of context.
I haven't seen those before, but I'm going to have to check that out because that sounds like a great idea to engage them. And especially like if you're in a, like, we said the younger grades do like stations kind of thing, so that could be something that y'all could do. I mean, you could do as a group, and then that could be a station that they continue practicing that skill. And then one of the things that I love doing with mine, kind of playing off what Michael said, but it's a little less, it's very unplugged is what we did. So writing sequence of like how to navigate around the building, and then having to go around the building with your partner and debug what they wrote, their program, kind of. Like getting from my room to the front office, how would you tell somebody how to do that? And they would come back and be like, we only made it, a third of the way there because we found this error. So they would sit down and debug that. So just like, and then, letting them get up and walk around, and again, that communication aspect came in. So I thought that was pretty beneficial for them. All right, anybody else?
I had a lesson that I worked on with a second grade teacher, and I took more of the coaching role, but I did help her design the lesson. And she checked out one of our STEM kits that's the Ozobot, or Ozobots, I think they call them. Right, yes, I wasn't quite sure how little bitty hands would handle those, and they're very small. They will run right off the table if you don't watch them. But they were so excited about using those, and they did a lot of preparation before I got there the day I went to co-teach the lesson. But weeks before, I had worked with the second grade teacher to plan the lesson, and what I think really she appreciated and got more invested in it was because it was going to apply directly with the math concepts that she was teaching on measurement. And so for teachers that aren't already super innovative or ready to take on that next, newest thing or bring this into their classrooms for all of their students, tying into their curriculum is key. And so for these little guys, the little Ozobots, to tie into her math lesson was super important. But what the students were able to do with the criteria they got, and they built a little path and they measured it out. When I got there, they were pulling tape. They had tape on the floor and used expo markers on the floor. I hope it came off. But they were just so excited to show me how they had worked in groups of 4 to make their little track for their Ozobot. And then when they ran them, they didn't run their own. They switched, rotated around and ran their Ozobot on someone else's track to test it. And then some of them had to erase or remake their lines because, they had messed it up. So I thought that was one of my favorite lessons of the year also.
That's awesome. And you said measuring, so they could really be pulling in those math skills. I know that our third graders are constantly working on measurement. Really every grade, but especially those. They just really start diving into it. But you could throw in that aspect too. That's great.
Right. And she told me first thing, this is new, brand new to them. Some of them are just learning the terminology associated with measurement. Like she even had some of them measuring a whole meter. That group was really challenged. They struggled with the meter and a half. So the criteria she gave each group was different, and it was very high level.
That group would have probably done better if we lived in Canada, where they use the meter. Yeah. All right. So my next question is just the same kind of thing about what skills we want this group to have. So we kind of talked about communication and collaboration, problem solving with the little ones, K1. So what skills do you think are, best case scenario, they walk out of second and third grade having mastered these skills?
One thing I think that's important for this grade that may not be ready yet for the kindergarten to first graders is the idea of learning how to experiment and iterate. We call that tinkering. So I think that's kind of what Angela was mentioning in her last, description is, students understanding that they may need to, make a mistake and then come back and just continually improve. So I think this grade level, that skill starts to become really important for them to learn.
I think also it's important for them to understand that there are different solutions can exist for the same problem. And so by not just stopping at the first solution, see how else, because I think that's the way they can make things even better and take things and tweak. So that's where we really start kind of, how else?
Mm-hmm. Yeah, that's a great point. And it also kind of builds on that collaboration and communication because you realize that 2 people can solve a problem in 2 different ways, but they still both solve the problem. So opening up lines of communication and understanding. There you go. All right. Y'all ready to move to 4th and 5th? I got to be honest, 4th and 5th are my favorite grades. They really are. All right, so resources or lessons that we used or were your favorites for 4th and 5th grade this year? Anybody want to go first?
Well, I'll get started. We have a very fortunate we have one of our elementary schools that chose to do school-wide intervention and enrichment at the exact same time, because normally schools will do it where 5th grade may have this hour, 4th grade may have this hour, but by doing it all at the exact same time, we were really able to utilize people that we had not been able to do before at the same time. So we offered also some out-of-classroom enrichments, and so I volunteered, and I used CS First with Google's coding club. And so I did game design with a group, and then I did fashion and design. I think I actually used music and sound, I believe, and some others. And so that was a great way to, so the resources were already there. It's just like with Codeorg, it has experts that are giving the instructions, so the facilitator doesn't have to know everything, and I think that's important to educate our teachers, is you don't have to know everything, but let's find the resources that will bring those experts in and be diverse experts too. I think that's very important. And so going through that with the students on a weekly basis, I got to see how that worked. And man, my game designer kids, I had 19 kids, and we met in the lunchroom with Chromebooks, and they were all about it. But also we took it, I think it's important for people to know, just because a lesson is written doesn't mean you can't expand upon it. Because one of the things I was struggling with at first is all the kids put on headphones and nobody talked. And so I made sure to build in those times, turn and talk, get feedback, because that was one of our big things. It was always in our vocabulary. What feedback have you gotten today? Who have you gotten it from? And I wanted them to get feedback not only from their classmates, but for others who were not even a part of our group, and then from parents and community members. And so that was very important for us, is getting that feedback. But it was just nice because I had not taught computer science before and had not gone through any training yet, and so I did not feel adequate enough. And so having that and going along with it as a student, but that was something that we've used and will use. Again, they had quite a few different different themes, and so I know there's an animation one, and there's things I think that the kids are interested in, and I think that's very important too. So I did the fashion and design, and I think the girls that chose to take that class didn't really read all of it. They just saw fashion. And so when getting in and doing the coding, only about half of them were like, oh, this is not what I thought it was. But we were able to really get in some, and they were like, oh my gosh, look, I could be a designer. And so that, to me, that was the aha moment when they would walk out and go, I am a game designer, I am a fashion designer, rather than it's not something I could ever do. And so that was powerful to me. So I really liked that curriculum too. We also used, thanks to Vinny, who's on here, who introduced me to Code Combat. So my kids who were like, I am so beyond, that I can make games in my sleep almost. So we took them to the next level with Code Combat, and so that's teaching them gaming using Python or JavaScript. And so it has a whole different vibe. It's very kind of immersive, and so some of my kids are like, yes, I can battle, and I can do, and so just gave a whole different, it attracted different groups. And I think that's what we have to look at, is when we're finding resources, is look at all your different students and what are their interests. If nobody's interested in gaming, which I know all of them are, but if, find something that's going to hook that one. So those are two that I really loved and got to experiment with a good bit. We actually ran Code Combat for our after-school program. Because if you think about it, you've got a lot of kids sitting in after school. That is a great resource to pilot things, to test some things out. And I know our after-school directors were very excited about it because it gave them just some enhanced learning. So those are my two for the district.
Well, April, you stole both of mine. Oh, no, I'm just kidding. No, I used Code Combat with 3rd, 4th, and 5th this year. And up to, I was just typing this to put in the chat box, but up to level 20, you don't have to buy the license. And right. Up to level 20 is the whole intro to computer science. So you have like looping and all that kind of stuff in there. So you get all these moments you get all the basics in there, I guess. And then you can really pull those out and work on them if you can't buy the license. Because I probably have 300 students on my Code Combat account, but I haven't paid for any of it because they were using up to 20. And then I was going to, make a decision once we got to 20 about who was going to keep progressing on and who wasn't. So, but that's just another great, free thing that is excellent. And now my kids are using Python and being ogres and hiding from fire pits and stuff. So, an excellent one. Just finishing my typing. All right, anybody else have a resource question?
Yeah, so in the 4th, 5th grade level, I'm really excited about the intersection between analog and digital fabrication and computer science. And I think around 4th, 5th grade is a really interesting opportunity to do that, and particularly in terms of mitigating the gender gap that starts to occur around 5th grade. So we've been messing around with a lot with microcomputing, like Arduinos, in that space. The challenge has been that Arduino's, the programming language is very syntax-based, right? And so generally, it's been a difficult sort of on-ramp to figure out how to get kids capable of making things that were meaningful to them, that they could code, and it was there was enough robust coding required to do something more than make their LED blink. But Tinkercad released their circuits side of Tinkercad, which had always been a staple for 3D print design. But when they released the circuits side of it, they have Arduinos in there, so you can breadboard and prototype all digitally with your Arduino and code it in a drag-and-drop language, a drag-and-drop and syntax, or just straight in Arduino syntax, and you can test it. So it'll blow the circuit before you do it physically, right? So you can totally screw it up and learn through the iterative process. And we're really excited. We're seeing a lot of opportunity in 4th and 5th grade to have kids doing that. We actually just had a 5th grade kid program an LCD screen to have a scrolling text display, which isn't wildly complex for microcomputing, but for a 5th grade student that had no formal computer science training, that was a pretty big deal. And he did the whole thing on Tinkercad and digitally, and while he was doing it, he did it physically in front of them with a $35 kit from an intro to Arduino kit. So he just had a ton of components in front of him and was able to copy what he was doing digitally and do it physically in front of him. But that digital space gave him an opportunity to iterate in a safe environment. And so I think we're seeing, especially for female, we talk about the gender side of that, for female students, when we ask 5th and 6th grade girls, what do you want to make in computer class, they always say an app. They want to make an app, but they don't have the foundational skills to make an app that's authentic, right? And so they know when you take them to an app inventor type of site, they're like, yeah, that's cute, but I want to make an app that's meaningful, that helps people, that has all these things. And by the time they realize how complex it is, it's a challenge. But I think with digital fabrication, right, microcomputing could bridge that gap. It gives them an opportunity to build something functional. We had I know that's not elementary, but we had a 6th grade student make an umbrella that she wired with a Arduino that just put touch sensors in the umbrella. So when it rained, right, the umbrella would light up. She had just wired LEDs so that when raindrops or whatever, but she'd demonstrate with Skittles, but hit the umbrella, lights would go off, right? So it's a simple way to onboard kids to this, I'm really interested in programming for meaning, but then, not having those skills yet, this gives them an opportunity, kind of an on-ramp, to be able to program in a meaningful way.
That's incredible that the 6th grader did that. I mean, I love that. And
the code behind it's really simple, right? It's not really that difficult. Yeah.
Awesome. Taking things back to the unplugged realm, I guess, because, I keep doing that. One of the things that I really harped on this year, I guess, is a cyclical thinking or design process, which we've all heard of design thinking and engineering process. So really tying in those computational thinking skills with these kids, which is kind of the next question, but I thought I'd go ahead and talk about it now. My students were super interested in the hurricane season we had this past year because, it was historic. We had something like 11 hurricanes make land, and normally we have 4. So I took their interest in that, and we kind of designed this design project around that, where they were really engaging their computational thinking skills and having to go research how hurricanes impact communities. So they're using that digital literacy component there. And then they had to actually design their hurricane-proof resistant shelters out of recyclable materials. And then we tested them, and then they made improvements on them and then tested them again. So just kind of pulling away from the actual computer or the actual robot, like that was a really great experience. I wasn't sure that I was going to be able to apply that to computational thinking, but it just flowed perfectly together. And that I was able to pull in science and research with writing skills and math skills into all of that one lesson that wasn't necessarily computer-based, but it had so many computer science skills ingrained in it. So that was really awesome. And seeing their houses was, we used a leaf blower to test them, so that was great. Great. All right. Anybody else for 4th and 5th? Good. All right, so let's talk about the skills that we want these people to have when they are really thinking about leaving elementary school and moving on to those middle school skills.
I think we've said a lot of them that really are recurring throughout all the standards, but what I really want my 4th and 5th graders to understand is technology, the majority of technology that's made is because it's someone needs something. They want to do something better or go, and that it can really influence how you do things. For example, I didn't want to cook dinner tonight, so I just got my waiter app out and called up and said, what do you guys want? And so just having them see that there are things created for others to make life easier or to, to assist those who can't read or can't see very well. I would never travel anywhere without my map and, on my phone or using Waze to know when there's, a pothole here or police here or things like that. And so just having them understand that there's a reason for everything, and it's because somebody had a problem or somebody wanted to do something better. And then I want them to also understand that there's a way everything happens. It's not just magical. So that really is too. So sometimes they'll go, well, the Wi-Fi is down. I bet somebody, just stepped on it wrong. No. So they help them understand how it gets to the places and to moving back. So I want them to see it just doesn't, appear. There's processes, there's networks, and there's things in place that makes those happen. So I'm excited about that. And then, like I said earlier, perseverance. But I know in our new course of study that we worked on for Alabama, 5th grade, we did a lot of, that's when they would publish for a larger audience. So we went from lower elementary just to talking and working and explaining within their class. We really want our 5th graders to share their knowledge outside of their classroom walls, outside of their school walls. So publishing their findings, publishing their data, presenting their designs that they've made that have real purpose to it. So relevance is critical too. So those are just some of those things, skills that I'm super excited and wish for all 4th and 5th grade.
Yeah, for us, we focus a lot on, we believe, especially by 5th grade, that recursion should be something that they're starting to think about in a meaningful way. They're capable of coding complex enough programs that they can see the need for it, right? The need for recursion starts to develop organically, so it's an interesting opportunity to do that. And I think too, I haven't heard it said tonight, but I'm sure we all think it and believe it is at some point, probably by 3rd or 4th grade, starting to instill some digital citizenship skills. And while that's not the basis of computer science, it certainly is a component. Thinking about security and what's appropriate use of technology and when is it appropriate to, what's the difference between collaboration and cheating, right? Those kinds of conversations that I think they're ready for, and the stage is set around that age. We want to see by 6th grade that that's not the first time they're seeing that.
I know we've talked too about making sure students know when something is automatically collecting your data and you have to know to turn it off.
Right.
And you have to know what information you're putting out there, and that could last forever. It's not just going to disappear. Yeah.
I think as they begin to move beyond puzzles and maybe even not using block languages anymore, in some cases they have open environments, the importance of abstraction, so they may be cognitively more open to abstraction now. So if they create their own blocks and they get procedural abstraction, I think that's a really helpful skill at this age that coding can bring about. And I would love to have all elementary school teachers doing coding, getting deeper into logic at this phase. So the story I often mention when we do the CSF workshops is how many college freshmen do not know the difference or can define the word and or logically, and do a truth table or try to explain what that means at 4th and 5th grade level, so we don't have to do it later in college when they those things I think can be learned at that age. You can begin to look at, I think, classic algorithms in computer science. What does searching and sorting mean? And one of the upcoming questions about resources, there are CS Unplugged activities about that, where there's kinesthetic things where they can learn about those algorithms that are classic things, but at this grade there's lessons for those. And I think so April and Michael kind of touched on this too, is begin to be reflective about the world they live in and noticing the global impact of computing and where computation applies in their life. It's not magic anymore. It's there's some things that are really happening, and the wonder and awe of that, and how they can then be inspired by that to be creators of their own things in the future.
Jeff, that's what I was going to mention is getting kids to realize that they should not just be consumers, that they should be producing things too. So, and I've talked about that with my work with fifth graders. I know you can't just consume. Let's start trying to build. Let's start trying to produce, create solutions to problems.
Ashley, can you hear me?
Yeah.
Okay. Well, so let me know if I'm not clear, because I move around a lot with these ear pods or whatever they call it, earbuds in my ear.
You're good.
So Dr. Gray made a great point about kinesthetic and some of the things they should be doing or should be able to do at these younger ages. And I learned this from Dr. Gray's class back in 2015. It was an online thing for CS principals for high school teachers. And some of the stuff they're teaching at the high school level, we can be doing that in middle school and even in 4th and 5th grade. So some of the things I do as a result of taking that course, so that's not me, it's Dr. Gray, about binary bits and bytes and nibbles, and how those things can be represented with simple cards with dots on them. And so you can line them up in order the way they should be lined up with the binary, and you can ask them, show me 16. And then that one bit for 16 would pop up to say, hey, I'm right here. There's one of me in this position, and like with kind of like placeholders with the way our decimal system works. And it gets the students up out of their seats, and they can see it, and then you rotate students through that. Okay, now let's count up 1, 2, 3, 4, and there's a pattern that develops where the students can see that when an odd one is up, that first bit is a 1, and when it's an even number, that first bit is a 0. And so then we move on, and they decode this message that I think came from CS Unplugged, or the message I may have found from someone else, but CS Unplugged has a very good packet that you can download on binary, and it's all completely unplugged, and it's all CS foundations, and so they decode this message, and then beyond that we move on to algorithms, and what algorithms are. It's just a series of steps. Then you make a sandwich. We also have them take that, so they'll write steps to make a sandwich, and then from that I'll say, well, now let's look at an algorithm for your life. And then we also incorporate that into pseudocode. So let's write an algorithm in pseudocode about your daily routine. So what does your process look like from when you wake up in the morning until when you get to school? So I'll write that out in pseudocode, and then we take the pseudocode and we say, okay, you've done that. Here's another form of pseudocode that can be displayed in a flowchart. So then when I introduce them to selection, and that's basically just decisions if, conditionals like you even mentioned, and then also brings in comparative operators, and it's true this, and it's false that. And so they have to write out their pseudocode that they made into a flowchart, and then they can use that in Google Draw, or they can do that just with pen and paper. And there's so much more. I feel like I'm already talking so much, but there's that just builds. I mean, that's like a 3, 4, 5 week unit. And the only reason we touch a computer is because I want them to get to the ASCII, which will decode the binary to a character, binary to decimal to a character to get their message out, and then and some other things that I want them to do, like use Google Draw and just use some technology tools. But all of that can be done completely unplugged and we talk about computational thinking, and that actually brings us into the introduction of algorithms and the sandwich and all that. And I've got a great unit on that I stole from somebody, and I am more than willing to share that out if that will help. But I feel like it's been awesome for the computer science, like fundamentals, just the foundation of it, for my kids to understand what it is we're trying to teach them. And they can do it in 4th and 5th grade. Thanks again for your time.
Yeah, hey, that would be awesome if you could share that in the audience chat.
Yes, it's going to be a Google Drive.
Okay.
Actually, can I add on?
Yeah, go ahead.
When Dr. Gray was talking earlier, it reminded me. I think the other thing that I hope to see by middle school, it's less skill and more philosophy, but I hope to see kids that show up to middle school seeing computer science as a problem-solving tool, right, as opposed to its own standalone, like, siloed subject. I hope that they see it as an integrated tool that they could use within the context of the other core content areas, right? Like, I'd love to see them thinking that I've got an interesting math problem. Computer science is a way I can work to solve that problem or to demonstrate my mastery of those skills, as opposed to I go do computer science separate from my other content.
Yeah, that's a great point. I know for the Alabama just passed, Stella asked about our standards or content and sites. So I'm going to go ahead and move us over to questions with this slide about audience Q&A, so that we can take a second to answer her question, because I know we'll probably have different input, and I think it would be really valuable. So our state in Alabama, we just passed the Digital Literacy and Computer Science course of study, which April put a link to it so you can see the actual course of study. We just passed that, or it was just adopted in March. So that's kind of what we're looking towards as far as implementation goes. Our implementation year is next year, so this next school year is optional, and the following year it's full implementation. But our goal is to really integrate. It wasn't designed, the committee did not design it to be a standalone content or standalone, oh my gosh, I'm drawing a blank, subject? Yes, in K through 8 especially. So that's really kind of where our thinking is. I was actually able to serve with April and Dr. Gray on that committee to form those standards. So that's something that we did. But I know that in our research, we also heavily read into ISTE standards. The CSTA, is that the other one that we really, yeah. So yeah. Thanks, Michael. Does anybody else want to share what specific computer science or local standards you use? Yeah. Michael, what does Tennessee use? Or what do y'all use to?
We don't.
Okay.
Yeah, we're at the state level, we're behind. It's kind of left up to teachers. We pushed, locally we pushed the CSTA standards, just their framework, just because it's something to go behind.
Okay. And I'll see if I'm going to try to get the CSTA standards linked in there for you, Stella, so you can take a look at those too. All right, anybody else in the audience have questions? Oh, thank you, April. Yay. I figured somebody would have them just really close by. All right.
Hi, Ashley. This is Melissa. I have a question for the panelists. This is something that always comes to mind for me is I just even talk to friends who are educators, and maybe computer science and computational is brand new for them, especially when you're talking about the elementary level. So if someone is just starting out, and I apologize because someone's outside doing my yard, so you may hear a leaf blower out there, but I'll get it out quickly. If someone's just starting out and they're still trying to kind of figure this all out on their own, and they just, they want to take the plunge next year and at least get something started, what would you recommend for them? Like where should they get started?
Google CS First has to be somewhere that you're calling and getting a hold of. It's a great onboard. Codeorg obviously has a lot of great introductory tools, but for me, it's less about where to get started and more about get started. right?
Yeah.
Like take the first step. There's probably a dozen great starting points, but the best advice I could give is don't wait till you've mastered it, right? We've got this model in school that says before you can teach something, you have to master it first, and I think it's an outdated model.
Yeah, not be afraid to be the expert, that sort of thing.
Yeah. I think it's important to, I feel like the shift in me as a teacher has gone from teaching and really standing up and leading everything to really being more of a facilitator, getting in there and doing that. Actually, that's one of, that kind of touched on one of my next questions. So if you're in the audience and you have another question, feel free to put it in the audience chat. But my next question before we get to more of tips on how to get started if you're just trying to get started, or like, I know, Stella, you said you're moving from, I'm guessing middle school to elementary, I'm not sure, but you said you were moving into elementary. But could y'all think about like 2 or 3 of your go-to spots for resources or to find lessons or activities, things like that? I know we mentioned Codeorg, which is one of mine. Yeah, April said the same. For Unplugged and Plugged activities, because their entire curriculum is online and not cheap. So, I mean, it is cheap. Sorry. It doesn't cost anything. So.
If you're using Codeorg, Kiki Prosper, who wrote a lot of the book and the curriculum, she has a YouTube channel called Kiki versus IT, and there are dozens and dozens of little short videos that she's done that are, I think, would be really helpful. And we mentioned all along the way the CS Unplugged site. CS Unplugged has been around since around 1995. I mean, this is long developed activities and pedagogy from Tim Bell in New Zealand and some of his colleagues, and they've revamped a lot of the stuff over the past year. So the website's been, there's a classic version and a new version, but those CS Unplugged activities are still really awesome. So teaching kids like error detection and, again, the classic algorithms, and then you mentioned about bits and bytes and pixels, and all that stuff is there. So if you haven't seen the csunplugged.org site, that's a must-see, I think.
Yeah, I think, did you share that or April shared that? Somebody shared it in the chat, so it's in there, the link's in there. Something else, too, just if you're starting, because I know we're going to kind of run out of time, so we're not going to get to that last question, but if you're looking for ways to connect with other educators in the same context as you, I really encourage you to connect with CS for All Teachers. It's a great virtual community. There's blog posts, webinars all the time about really excellent ways to integrate CS into your classroom. And then the community is just, like, I am no expert, but I feel like I have a lot more confidence in tackling things or trying new things because I know that I have these people to fall back on and get feedback from and get input from. So having that and finding those computer science people even on Twitter has been great. Knowing that you don't have to be the expert, like you said, you don't have to be the master of it. You kind of learn along with them. Great. All right. So I think we're going to wrap it up here. And Melissa has some events coming up that she's going to kind of talk to us about.
Thank you, Ashley, and thank you all so much, all the panelists, for joining us tonight. It's been great. I've loved hearing these ideas, and especially love seeing all the resources get exchanged in the chat window. It's wonderful. We do have a few upcoming activities here to close out the year. We have webinars on May the 29th and June the 4th. Benny will be hosting the one next week, a week from today, about choosing the right tool, the App Lab or the Game Lab, which are 2 tools offered by Codeorg. On June 4th, one of their colleagues, Deepa, will be talking about professional development opportunities for the CSP course, the Computer Science Principles course, and what's being offered by various curricula providers and others, just to give you a sense of kind of what's out there in the landscape. And then the other thing that I'd mention is we do have, so Ashley, Michael, and Vinny are 3 of what we call our community ambassadors. It's something that we started this year with the CS for All Teachers community and tapping into the great leadership of teachers in the classroom, or in Michael's case, outside of the classroom, they're still doing great work with teachers every day, and having them lead work with us for the community. So the deadline for the next cohort of applicants is May the 31st, and I will grab that link and share it in the window here. And I just encourage you to take a look, consider it if it's something that you've been interested in doing. Similar to what we've been talking about tonight, this is not something that the expectation is that you are the expert, but you still can be learning, absolutely, but just looking for great folks who are looking forward to leading and doing things like this and helping to host and organize webinars and other resources and things like that within the community. So we hope you will consider that. And then the last thing I would just mention is we always love to hear back from you and see how we're doing here on these webinars. So I'm going to include a link in the chat window there that we ask you to just take a very, very super quick survey that'll give feedback to our team about this session and other sessions to kind of think about how we can improve for the future. So thanks again, everyone. We appreciate your time, and we hope you have a good night. Take care, everyone.
Bye.